Excellent. I'm glad. So today we're going to talk about the laws of exponents. And again, for most of you, this is going to be review, but it's very important review because we're going to focus a lot on logarithms and logarithmic equations in this course. And you cannot do logarithms if you do not understand exponents. Okay? So we're going to go through the basic laws of exponents and look at some examples of each one. And that's what we're going to do today. How's that? So, first of all, in my world, it's an exponent. In your world, it's an index or indices. Or another word for it is power. They all mean exactly the same thing. Index, exponent, power. Okay? So, if you've studied indices, then you've studied exponents, right? So, hopefully you're okay with that. And the first thing we need to do is we need to talk about the basic structure of an exponent because that is, for some reason, the thing that drives people most crazy. Say we have some a to the n. Again, just using algebraic or general notation. A is called the base of the exponent, and n is the exponent itself. Exponent, power, index, whatever you prefer. Right? So, and remember, the n tells you how many times you multiply the base times itself. It's not the base times the exponent, but the base times itself n times, however many times you have the base. Right? Now, that part usually doesn't present much problem. The problem comes with which part is the base. So, the base is only the thing, and because the base can be a number, it can be a letter, it can be anything, lots of different things. Only the thing the exponent touches. Now that's just my way of explaining it. I'll show you some examples of what I mean. But more often than not, people try to make the base too much, or in some cases too little. So you have to be very careful. So, for example, all I want you to do is I want you to tell me what is the base, and we'll start off easy. If we have 4 to the second power, the base is, just the 4. So that means multiply 4 times itself over and over. Right? So that's no big deal. Most people are good with that one. Now, what if I have negative 4 to the second power? What is the base? The base is still 4. The exponent is not touching the minus. Therefore, the minus is not part of the problem. So you would write this, if you wanted to expand it, that's the same thing as saying negative 4 times 4. So multiply the two 4s together, and whatever you get, the answer is still going to be negative. The negative just follows along. It's not part of the exponent. Okay? That's probably the most common mistake. Right? What if I have negative 4a to the second power? What's the base of the exponent? The a, and only the a. Okay? Yes?
For the minus 4, the answer is still minus.
Exactly.
It's just that we don't.
So the 4 squared means multiply the 4 times 4, but you just keep the minus. The minus just is not affected by the exponent at all.
It's not minus 4 times
No. Because the base is only the thing that exponent is actually next to. Now, however, be careful. Say this right. What is the exponent touching this time?
Negative 4.
It's touching the what?
Bracket.
The bracket. So what is the base of the exponent? The bracket. And everything that's inside the bracket just follows along. Okay? So, yes, the negative 4 is what you're going to multiply together, but the base is actually the bracket itself. So you just take the bracket times what? Itself. Yeah? So the negative 4 inside follows along. Negative times a negative is a?
Positive.
Do you have to write the positive? No, but I'm going to always on the notes just for effect. And 4 times 4, of course, is 16. Okay? This is the only time that the exponent affects the sign, unless it's actually touching the sign, right? But get in the habit of thinking of the base of the exponent is not the stuff inside. The base of the exponent is the bracket, okay? Which I'm always going to call parentheses. But, so get used to it, sorry. The habit of being an American. Well, it makes me crazy because in the States, I'll go to back. Because in the States, that's a parentheses, that's a bracket, and these are braces. What do you call the squared ones here? What about these? Squiggly brackets? Oh.
These are braces.
Good job. Okay. All right. Well, anyway, so I'm adapting. I'm learning. There are some things I'm never going to say. I'm not going to call this a jumper. It's a sweater. But I will do the brackets because it's important to you all mathematically. How's that?
What do you call jackets?
Flip-flops.
I call them flip-flops.
Yeah.
It's
So to change the sign of an exponent, simply move the base and the exponent across the fraction bar. So if it's in the bottom, it'll move to the top. If it's in the top, it'll move to the bottom. Okay? Yeah. So like here. Where is it? Where is it? It's in the top. Okay? Here, where is it? So it needs to move to the top. Pardon me? No, it's in the bottom now. So where does it need to move? 2 to the minus 4? Where is it? Doesn't look like a fraction, but you can write everything as a fraction, right? If you don't have if it's not a fraction, say if you have a 5, it's 5 over 1. All right, guys, hold on. So anything is a fraction. Every number is a fraction. So if it doesn't look like a fraction, that really means it's in the top. It's already in the top. Okay, hold on. Okay, hold on. You're making it harder than it is. Where is the negative exponent in this? It's in the bottom of the fraction, isn't it? Okay, so it needs to move to the top. No, hold on a second.
If the question's asking you like that. So if the question has a negative.
Yeah, it's going to be very clear. So like here, 5 to the negative 2. Where is that? In the top or the bottom? Right, it's in the top. So it needs to move to the bottom. Right? 6 over 3 to the negative 2. Where's the negative exponent? So where does it need to go? There you go. Yeah. Now, keep it simple. Yeah. It's all right. That's why I'm here. Otherwise, I'd just hand you the book and say, come back to me when it's done. Right? Okay. Good job. All right. So here we go. So we've talked a little bit about some of those. Let's see. What else do I need to talk about? Okay. We also need to talk about fractions as exponents. These are all those basic rules that somewhere you were supposed to learn somehow and miraculously know them when you get here. And yet I've looked at all the curriculums and I'm thinking, I've never seen these in any curriculum anywhere up to this point. So I don't know where you were supposed to have learned them. So here we go. Fractions as exponents. If you have a fraction as an exponent, And again, I'm going back to general form because I don't want to use numbers because it applies to any number. If you have a fraction of an exponent, that's actually a root. Oh, y'all don't call them root. What do y'all call them? Surds? Do y'all call them surds or no? Okay. Root or a surd. That is the weirdest word I've ever heard in my entire life. You'll see it in your books written as a surd. It's crazy. I don't like it. Okay. All right. So where the denominator. Okay. So the denominator becomes the index, and I know that that's going to be weird because you're used to thinking of it as an index as an exponent, but you have a root. It's the nth root, okay, of a. Oh, I really shouldn't have used 1 over n, but that's okay. The nth root of a. So whatever that denominator. So it's going to be this. If it was 1/2, then it would be a second or square root. If it was 1/3, it's the third or cube root. Okay.
Wait, what do you mean by the
Okay. Well,
is that just what you call?
in life, in mathematics, this is the index. Okay. That's why I don't call exponents indexes. To me, an index is a specific thing. It's that part. Okay. Denominator. Sorry, I'm being lazy. The denominator. I'm used to my university students. They're trained. If I abbreviate, they're not allowed to.
I got it.
I wrote denominator.
I read the text.
So, yeah. So anyway, but I'll not do it. I will be good. I will be better. Y'all have to train me. You have to train me. Denominator becomes the index of the root. Yeah.
What happens to the 1?
All right. I will show you. Let's say we have A. That's why I said I shouldn't have used a 1. A to the B over C. Okay? That becomes a root. A is the base. C is the index. And B is the exponent on the base.
So you don't need to write the one above. Yeah, you don't need to write it.
You don't need to write it because it's a 1. Yeah. Okay? Now, put a big old or here, though. Because sometimes it's really inconvenient if that becomes the exponent on the inside. There are 2 notations to use for this. Or C root of A all raised to the B power. So you could put the B on the base on the inside, which means you need to raise it to that exponent before you take the root, or you could do it second. And it depends on the number. If making it a square inside makes it easier to take the square root, yay. But if it makes it some number that makes it really difficult, then raising it to the second power after you get the answer is easier, then you'll use it out there. So let me just think of an example. Hold on. Oh, this is gonna be hard. I'm not good at making up examples, or I'd be writing math books, staying at home, being rich. All right. So, say for example, you have 9 raised to the 1/2 power. Okay? Guys, come on. 9 raised to the 1/2 power. The 1/2 power literally tells you that it shouldn't be an exponent. It should be a root. And it's the square root of 9, right? And the square root of 9 is simply what? 3. Okay? What if it's 9 to the 2? Oh, let's see. That won't work. 9 to the 3/2 power. That's still the square root of 9. But you could do 9 to the 3rd power, but that's going to give you a huge number. So instead, I would rather do this. Take the square root of 9 and then raise the answer to the 3rd power. You'll get the same exact answer. So what's the square root of 9? But I still have to raise that to the 3rd power, which is what? Okay. Now, if you did the square root and then 9 to the third power, so somebody tell me what 9 to the third power is. It's 81 times 9. I need a number, guys. Y'all have the calculators.
I thought my brain.
Good for you. I have mine too, but that's no good for math for me. Yes? What is it? 729. And then hit the square root key of that. You hit the square key. Hit the square root key, and you'll get that. Okay, guys, focus back here for a second because y'all asked me to show you this, so here I'm showing it. So, if you put the exponent inside, that means you had to do the 9 to the third first, and you got a huge number, and then you had to take the square root of that huge number. If you put the exponent on the outside, that means take the square root first, which gives you a 3, and then raising 3 to the third power is a lot easier than finding the square root of 729, even with your calculator, right? This one you could do in your head, probably, most of you. But this one you definitely have to use a calculator for because I don't think any of you know the square root of 729.
You could find it.
Well, yeah, you could find it, but wouldn't it be easier to raise 3 to the third power? But either one of them is fine. You can use either one. You'll get exactly the same answer. Okay? All right. Good job. So, now let's talk about some operations, because this is what you're going to do for homework. Your favorite. Okay. To multiply exponents. Okay? On the same base. Okay, guys. So, that's the key right there. If you're multiplying powers with the same base, power is just another word for exponent. They have to have the same base, otherwise you can't do it. All right? So, can I take b to the second times c to the third? No. So all you do is just stack them and gives you b to the second, c to the third. You can't really multiply them together, but if you squish them together like that, it means multiply, right? Okay? So you can't multiply them. But what if I have b to the second times b to the third? Is that the same base? Yes. Are you okay with me using a dot to mean multiply?
Yes.
Okay, because you know I'm going to. All right. So if you're not okay with a dot for multiply, get there. You're old enough now. All right. So we don't actually multiply the exponents when you do that, right? Because what that really means is b times b, right, from the b squared, times, right, does that multiply? B to the third is b times b times b. Count them up, and that gives you b to the fifth power, right? So because it's all multiplication, instead of having to expand it out every time, you use the shortcut, and here's the process. Keep the base, stays the same. So if the same thing, if it was a 4 to the third, it would stay a 4. The base would stay a 4. But add the exponents.
Wait, if you had two different, if you had like a thing like 3 to the 2 and then 4 to the 2, could you like...
Well then, if they're numbers,
the same?
if they're, so like 3 to the second times 4 to the second,
Yeah.
what you would do is just use, that's not exponents, that's order of operations, right?
You just multiply those.
Yeah, so that's order of operations instead of, yeah. These rules are using exponents are mainly for variables.
Yeah.
Okay? All right. Good question, though. Excellent question. All right. So keep the base and do what to the exponents? Add them. Okay? So let's just do a few examples from your book on page 7 there. Let's see. We have 15b to the 10th times 2b to the 5th. Well, 15 times 2, those are just numbers, right? That's just 30. B to the 10 times b to the 5th is b to the 10 plus 5. So that gives you 30b to the 15th. Now, do you have to write this part? No, but I'm going to because I'm trying to teach you something. So I'm going to write everything so that you can see it. If you already know this, then you're good. But if you're shaky on this, then I would write the pluses and do the addition and subtraction. Can you ever write too much, you think? Not usually. I mean, as long as you're showing your work, can you ever show too much work? Is what I should say. Could you write too much? Yes, you could make me insane. But, right? But could you show too much work? No. How's that? Rephrase that a little bit. Okay? Now, all right. You didn't like the decimal one? Is that what you were saying? Y to the 2.5. Oh, you just were surprised to see it. Yeah, it is a little odd. What operation? Multiplication. Do I have the same base? Yes. So I keep the base, and what do I do to the exponents? Add them. So 2.5 plus 3.1. Remember, when you're adding decimals, you just line up the decimals and add. Becomes y to the 5.6. But of course, you could also use your calculator if you wanted to add those in your calculator if you just got crazy. All right?
What about the ones with the brackets?
Okay, so like number 10?
Yeah.
All right. Again, that just goes back to the order of operations. So 0.404 times negative 3y squared in bracket. Okay. Now, you have a bracket. That means you have to deal with that first. So we're not going to deal with this part. We're just going to bring it down. Can you do negative 3y squared? Is there anything you can simplify that? Negative 3y squared? You can't, because the squared part is only on the y. Can you square a y? No, because we don't know what it is. And we can't do anything with the negative 3. Is there an exponent on the bracket? Nope. Is there a multiplier right up front? Nope. So it just becomes times negative 3y squared. Just get rid of the bracket. But you have to use the order of the rules for brackets. And then what's a 5 times a negative 3? Positive times a negative is negative. 5 times 3 is 15. Are the bases the same on the two exponents? Yes. So keep the exponent, and what do you do to keep the base, and what do you do to the exponents? Add them. So it's 0.4 plus 2, which is 2.4. So again, if you see a bracket parentheses, then just do it first. Yes, I'm sorry. Mm-hmm.
Would it be to the 8? Because that only just pretends a 1.
For which one? Number 4. Right, that's a good one. That's a really good one. So you see you have y to the 3rd plus y to the 4th. I'm sorry, times, not plus. Times. Now, so do they all have the same base? Yes. So I'm going to add the exponents, but what's wrong with that one? It doesn't have an exponent. So what do you assume the exponent to be if you don't have one? A 1. Yeah. Guess like that.
Could you please go back to that page?
You bet I can. So y to the 8th when you add them all up. Okay. All right. Yes.
How do we get, because just looking at number 5,
Mm-hmm.
I mean,
Just
number 3, it became 30b to the 15 power, correct?
No. It's just the 15 times 2 gives you 30, but remember the number is not part of the exponent.
Yeah.
Right?
Yeah, but, so, if there was a number before 11 times the numbers by each other, but, I'm just confused with, like, for example, number 5, there's 2z to the second power and 4z to the second power. You just do 6z to the...
Well, not 6, because it's multiplied, so 2 times 4,
Oh, okay.
which would give you 8z to the 2 plus 6, which is 8z to the 10th. Yeah. Remember, numbers we can multiply, just like we always did. Okay? And watch those signs, like on number 7. It's a negative times a positive, so it's going to be negative 6. So be careful with your signs. Okay? So, let me let me go through, and I forget that y'all haven't been my students, so I haven't beaten this into you. So a term has 4 parts. All algebraic terms are made up of 4 parts. First part is the sign. Second part is the coefficient. And I know you've probably heard that word before, but even if you don't know what it means, it's a simply fancy word for a multiplier. Third part is the variable. And the variable simply means the letter, A, B, Z, whatever. And the fourth part is its exponent. Okay? So if I have negative 4a to the third power, that's an algebraic term. It's algebraic because it has a letter in it. If it didn't have any letters in it, then it would just be an arithmetic term. So an algebraic term has 4 parts always. What is the sign of this one? It's a negative. Okay. What is the coefficient? It's just the multiplier, which is just that number part. So the coefficient is the 4. The base of the exponent is the a, and the exponent itself is a 3. Okay? So so what if you don't see a sign? You assume it to be a what sign? Positive. What if you don't see a number in front of the a? What do you assume it to be? A 1. So they still have coefficients and signs even if you don't see them. What if you don't see an exponent? 1 also. Okay? So, let's talk about how to multiply. Yes, in order to be an algebraic expression, it has to have a variable. If it's not, then it's just a number term, right? Just like an arithmetic. To multiply terms, there's 4 steps. Imagine that. How many parts are there of a term? 4. So it's 4 steps. First, do the sign. Positive times positive, negative times negative, etc. Second, multiply the coefficients. And again, the coefficient simply means the number part. Okay? Third, keep the base. And fourth, add exponents. Okay? So you always think about it in those ways. First, the sign. What's the number 1 mistake in algebra? Sign errors. Do the sign first, then do the numbers, multiply the numbers, keep the base, and add the exponents.
Can you write an example up just like underneath?
Sure. Negative 4x to the third times, 2x to the fifth. Right? Negative times a positive is a negative. 4 times 2 is 8. Keep the base and add the exponents. 3 plus 5 gives you 8. Shouldn't have used one that gives you the same exponent and base, but sorry. That's the base and coefficient. Yeah? So sign first, then the bases, then the coefficients, and then keep the base and add the exponent. Yeah. And what is the base of the exponent? X. So that's why x just stays the same, right?
What if they were different?
Well, then you can multiply them, you just stack them. Right? So like a squared times b squared is just a squared b squared. Right? So just keep the base and exponent because there's nothing to multiply with. Okay? All right. Yeah, if there's no variable, then it's not an algebraic expression.
Minus 4a, our variable is a, right?
Right.
So the variable could be the 4 if it was like no a, like 4 to the power 3.
No, a variable is always a letter. So if there's not a variable, so like negative 5, then that just means it's just a number. So it's just a number term. It's not algebraic. So it's not algebraic if it doesn't have a variable in it. So it wouldn't have all of these parts. These are algebraic terms. Sorry.
And the exponent also has to be there.
Well, it doesn't have to be there. What if it's not there? It's a 1. Yeah, everything has a power, but if it doesn't have one, then it's a 1.
We're talking about exponents, right?
Right.
It's always going to be the exponent parent. Yeah, but it's not there.
Yeah, but even -5 has an exponent. What's the exponent? Yeah, everything has an exponent, no matter what. But not everything is algebraic.
If let's just say like with like I know having like that just something straight over like divide fractions out of the powers and stuff. If you have like let's say like y/4 and then you have something y/6 and then you like
Okay, yeah.
read them out. But does the top one do you have to have like a 1 over something?
Right, yeah, if you get a negative exponent, you have to change it. You have to move it. Yeah. Okay, how much time do we have left?
By time. About now it's on.
Oh, there it goes. All right. Well, next time we'll talk about dividing powers and powers of powers again. A lot of and then they go through negative and hey, they do go through fractional exponents. Good for you. And so you move on. So we'll go through these exponent rules, and we're going to go through them pretty quickly. I used up most of the time because I didn't know what we were doing today. So